Hi everybody, welcome back. So in this video, we're going to be looking at equations, specifically linear equations, and we're going to work on how to solve them. So some of you might be familiar with this already, you might have done this, but it might be a long time. So let's talk about what a linear equation is. So in order to do that, we have to start with the idea of what is a line. How do we define a line? So I want you to think about that for a second. If somebody asked you to give the definition of a line, what would it be? So the basic way that we differentiate a line from all other types of shapes and functions, anything else that we talk about in this class, is that it has a constant rate of change. Okay, let's think about what that means. What is a constant rate of change? Okay, so a constant rate of change is that as time passes or as anything passes, the increase remains the same. Okay, so that can be a little bit crazy because what are we talking about with as time passes? Sometimes it's not time, sometimes it's something else. Let's think of a few examples of what might be linear. I want you to think about going in an elevator, okay? An elevator has a constant rate of change. It takes the same amount of time to go from one floor to the next. So if you're going from floor 1 to floor 3, let's say it takes you 5 seconds to go from the first to the third floor. What this means is because it's linear, to go from the third to the 5th floor, it will also take you 5 seconds. Okay, it's constant. That change is constant. You might see this in terms of price. Okay, if you buy 2 notebooks and it costs you $3, if you buy 4 notebooks, it's going to cost you $6. You're buying double the notebooks, so it's going to cost you double the price. Okay, we could think about it even in terms of escalators. Escalators, there's a constant rate of change. The time that it takes you to go from one floor to the next is the same. The number of escalator steps to go from one floor to the next is the same. So because that change is constant, we say that this is a linear change. Okay, I wanted to see if you could think of some more examples on your own. That's something that you're going to have to do. So just be aware of that. Okay, so I'll just put in here the example of the elevator so that you have it written down for you. So an elevator has a constant rate of change, and you can say the time it takes to go from one floor to the next. You could even say the distance from one floor to the next is the same, okay? And I'm using 2 floors in this example because I want you to understand that we're not always going up by 1. Okay, it doesn't matter what we're going up by. If we went from floor 1 to 10 and then from floor 11 to 20, it would take the same amount of time. Okay, it takes the same amount of time. Again, as we said, it can also be distance, where it's the same distance from floor 1 to floor 3 as it is from floor 3 to floor 5. Okay, and when we give examples in this class, and we will be giving lots and lots of examples, I want you to understand that these examples are assuming that things work. So in other words, if the elevator is broken and all of a sudden it starts falling, then you're not just, it doesn't take you the same amount of time to go from, let's say, floor 40 to 30 as it does to go from 30 to 20, because an elevator in free fall speeds up as it goes. Okay, so we're assuming that this elevator works. Okay, so what is this change called? So this change has a name. Again, some of you are familiar with it. It's called a slope. We're going to be spending a lot of time on slope when we talk about graphing linear functions. So it's a rate of change or a slope. And since we're going to be solving equations, let's think about what it means to solve an equation, okay? So while I'm writing, I want you to be thinking. And this could have many meanings, okay? We're solving an equation. We think about solving for the variable, okay? We can also, and when we say solve for a variable, one way that we're thinking about it is isolating that variable. We're saying what value is going to make this equation true, okay? We want both sides of the equation to be equal. So what values are going to make both sides of an equation equal? And if you remember, in the last video, we talked about order of operations and we explained the difference between an equation and an expression. So here we're not talking about expressions anymore. We're talking about equations. So we're finding values that make the equation hold true. So what do we mean by this? The left side has to continue to equal the right side. So let's look at some examples of linear equations. And these are not equations that we're going to solve necessarily. The first couple we're actually not going to solve because I'm going to include two variables in there. So the first one may look like this: 2x minus 6y is equal to 12. So notice that we have both an x and a y here, okay? Which means that if we're solving for y, let's say, if we're getting y all by itself on one side of the equation, what we're doing is we're finding all different values that we could put in for x, and it will give us a line. So we'll talk about this more when we're graphing. But when we solve for y, when we get y by itself in a case like this, okay, we've done this, you've probably, again, you might have done this before, but if you get y by itself on one side of the equation, what you're doing is you're saying any value that you plug in for x will give you a point on a line, Okay, when we have both an x and a y, that's what we're doing. So another example of that would be if we had something like 3x minus 4 is equal to y, or I'll even stick in a 5 here. Okay, 3x minus 4 is equal to 5y. So these are linear equations, and one thing that I want you to notice about this that will be true of all linear equations is that the exponents of x and y are both 1. This is how we know it's linear. Remember, if there is no exponents, then the exponent is 1. Okay, so what this will result in is a line. Okay, and what we're doing when we're saying that we're finding values of x and y that make this equation hold true, we're saying if we plugged in x equals 3 and y equals 5, does 3x minus 4 equal 5y? And if it does, then the equation holds true. If 3x minus 4 does not equal 5y, then the equation does not hold true with those values. Okay, now don't worry about that too much. We're going to be talking about, again, we're going to be talking about that much more when we graph. For now, we're going to look at equations, linear equations that only have an x in them, and we're going to solve those. Okay, so let's take some really simple ones at first. And I say that they're simple because you don't have to do very much. Okay, so I'll put these down, I'll write these down, but then after I write them, we're actually going to solve them. And hopefully you're familiar with how to do this, but if you're not, just take it slowly. Okay, so let's just look at those three. Okay, and again, to solve, so again, we know it's linear. X only has an exponent of 1. We don't see an exponent, so the exponent is 1. And what we want to do is we want to solve these. So at the very end of the last video, I said, when you're solving an equation, to isolate, what you do is you essentially go through the order of operations backwards. Okay, so I'm going to solve it in one way. Now, some of you may have many different ways to go about solving an equation. You can use whatever method with which you're familiar, and I am absolutely okay with that. So this is one method for people who maybe have never learned this before. Okay, so let's go through and just solve each of these three, and then we're going to look at some other types of linear equations that might be a little bit more complex for you. So let's take 3x plus 8 is equal to 24. And let's just go through how to solve this. So you're going backwards in the order of operations. So in the order of operations here, we would be multiplying first, right? And then we would be adding 8. So what we're doing to solve the equation is we're actually going to get rid of this plus 8 first. And in order to get rid of the plus 8, we're going to subtract it, right? Plus 8 minus 8 is 0, so we can subtract it. But if we're doing that, we have to do it to both sides, because the whole idea is that we never change the equation. The equation always holds true, okay? So you want to get rid of this plus 8 first. So in order to do that, we can subtract 8 from both sides. And now it's just the plus 8 and the minus 8. We can cross it out because it's equal to 0. And what we wind up with here is 3x is equal to 16. Okay. And then we want to get rid of the 3. So this is 3 times x. To get rid of the 3 times x, we divide by 3. We're doing the opposite. So we're dividing both sides by 3 here. And that means that our final solution is just x equals 16 over 3. Leave it as 16 over 3. I know some of you are going to want to put it as a mixed fraction. So if you are thinking that you would like to write this as 5 1/3, do not do that. You leave it as 16 divided by 3. That would be your answer. Do not turn it into a decimal. Okay, you leave it. We call this an improper fraction when the numerator is greater than the denominator. You leave it this way. And the reason why we leave it this way is because fractions can be difficult to work with, but mixed fractions, fractions with whole numbers and fractions like 5 1/3, they're so much harder to work with. This is the easiest way to work with a fraction. Okay, and the reason why we tend not to turn it into a decimal is it's not accurate. Okay, you would turn this into 5.333 and we're rounding. It's not accurate. 16 over 3 is the most accurate answer that is the easiest to work with. Okay, let's take the next one. So it's very similar. Okay, the last thing that we would do to if we were to plug in a value for x on this side would be to subtract 6. So we're going to do we're going to get rid of this minus 6 first. And again, we want to keep both sides of the equation the same. So if we need to get rid of this minus 6 by adding 6, we add it to both sides. And this 6 cancels. And we get 4x is equal to 31. And then we're going to divide both sides by 4 to get rid of that 4 over here. So here the 4 cancels, here the 3 canceled out. We were able to cross it out. So our final answer is x equals 31 over 4. And you should always be reducing your fractions. In these two cases, we can't reduce, meaning there's no common factor of 31 and 4. Okay, and we definitely will come up with examples to this at some point. I just don't know if I know the next one doesn't have that either. So, but throughout the semester, you'll see so many examples. So our last one that we have here is 7x plus 2 is equal to 35. And again, wow, that came out dark. Again, in that case, the first thing that we would do is we would get rid of the plus 2. So we subtract 2 from both sides. Notice we're using the opposite operation. We're not going in the opposite. We're not just going in the opposite order of operations. We're also using the opposite operation. So we get 7x is equal to 33. And then we just divide both sides by 7. And here, again, 33 and 7, they don't have anything in common. So our final answer is just 33 over 7. Okay, so these are the most basic linear equations. This is where we have the x on one side and we're just taking everything else and we're moving it over to the other side. Let's add a little bit to this. Let's take an example where we have an x on both sides of the equation. So let's say that we have 2x minus 5 is equal to 3x plus 8. Okay, and we want to solve this for x. So here the idea is that we get the x's on one side and the numbers on the other. And it doesn't matter which side each thing goes on. That's up to you. I personally have a preference to keeping my x's positive. Okay, so you're going to see that as a habit as I go through and I solve these. But you can absolutely do it your own way. And if you're not sure if your own way works, then just send me an email. Okay, just send me a picture of what you did and I can tell you. So here, we want to get the x's over first. Now, you can do this at the same time. So I'm going to do that, okay? I'm going to get you into the habit of doing it at the same time so that you save some time on your own. So I want you to think about which side you want your x's to be on and which side you want your numbers on. So let's bring this 2x over to the other side. And the way that we bring it over to the other side is we subtract it, okay? So we don't want the 2x over here anymore. We want it on this side, so we just subtract 2x from both sides. Notice we're subtracting it twice because we're working on two different sides of the equation. And 2x minus 2x is 0, so notice on that side, it goes away. Now, if we're moving the x's over to this side, okay, over to the right, then we're going to take this 8 and we're going to move it to the left. We want it on the other side. So actually, I'll do it in 2 steps on this one because I want to make sure that you understand what we're doing and that you don't get lost in the process. So what we get here is the negative 5 is still here, and 3x minus 2x is x, and the plus 8 is still there. Okay, now we want to move the 8 over. So in the next problem, we'll do this as one step. So we can subtract 8 from both sides. Notice we're subtracting because we need to do the opposite on this side to get rid of it. So if we're adding 8, we subtract 8. But because we're subtracting it over here, we have to subtract it over here so that we're doing the same thing to both sides of the equation and we're preserving equality, okay? And negative 5 minus 8 is negative 13. Don't be afraid to use your calculators, okay? It's okay. I'd love for you to practice adding and subtracting negative numbers, but I don't want you to get caught up in it, okay? There's so much other stuff that we do. So negative 5 minus 8 is negative 13. And that's what x is equal to. That's our final answer. Okay. And what this means is if we plug in negative 13 for x on both sides will be the same, okay? We get negative 31 on both sides, okay? Okay, let's take another example, and this time we're going to do it in one step. So let's say that we have 3x plus 1 is equal to 5x minus 7. Okay. So again, we want to get the x's over to one side and the numbers over to the other. And I'm going to move the 3x over to this side. I'm choosing to move the 3x because it's smaller than 5x. So when I subtract it, I'm going to wind up with something positive. See how I wound up with positive x here? So I want to wind up with something positive. You don't have to. It works the other way too. It just means that you're dividing by a negative number. There's nothing wrong with that. Okay. So let's do that. We subtract 3x from both sides. And since we're moving the 3x so that it gets crossed out on this side, that means that this minus 7 has to get moved to the other side, has to get moved over here. So how do we do that? Well, to get rid of a minus 7, we add 7. So we can actually do this at the same time just to save us a little bit of writing, but it's up to you. And now we just add. So 1 and 7 is 8, and 5x minus 3x is 2x. And you can see that it worked, right? We have numbers on the left, and we have our x on the right. And now we just divide both sides by 2, because we want to get rid of the 2 in front of the x. We want our x by itself. And here, 8 divided by 2 is just 4, so that's our final answer. And if you write it as 4 equals x or x equals 4, both of those are right. So I'm just going to write it like this, just so that you see that it's okay to do it either way. Okay, let's do one more. Let's do 7x minus 6 is equal to 11x plus 10. Okay. And here, let's do it a different way. Again, just so that you can see it makes no difference. Let's move the 11x over to the left. And that's going to make your x negative. Okay, if some of you are kind of looking ahead. But that's okay. That's the whole point. That it's okay if you wind up with a negative in front of the x. So if we're going to move the 11x over, that means that we have to subtract it from both sides because it's positive right now. And if we're moving the 11x over to the left, that means that we have to get rid of this 6 instead of the 10. So in order to get rid of the minus 6, we add 6. And notice we did it in just one step here. So the 11x went away on the right and the 6 went away on the left. And we should wind up with x's on one side and numbers on the other. 7x minus 11x gives us negative 4x. And 10 plus 6 is 16. Okay, and now this is what I mean. We just are, instead of dividing by a positive number like we did here, we divided by positive 2, we're just going to divide by negative 4. And this is an example of where you should reduce. Don't leave this as 16 over negative 4. 16 divided by negative 4 is negative 4, so you should write it as negative 4. And as we go through these videos, you should always, when you think that you're starting to get the hang of it, stop, do the problem on your own, see that you can do it on your own, okay? And then unpause the tape and unpause the video and make sure that you did it correctly, okay? Okay, let's add a little bit to this. Let's take some equations that require some knowledge of order of operations, okay? So let's take the following example. And okay, sorry about that, my computer crashed. So we were saying that we're going to create another linear equation. Okay, don't confuse long with hard here. This is longer to do, but it is not a harder problem, okay? And you just need some familiarity with order of operations here, okay? So if you remember, we deal with the parentheses first. Now these have x's, so we can't really add 7x and 1, but what we can do is we can use the distributive property. And the distributive property says if the operation on the outside, immediately on the outside, is exactly one level above in the order of operations, then the operation on the inside you can distribute. And we have multiplication on the outside, addition on the inside. So we can distribute here. So that's what we're going to do. We're going to distribute this 2 to both the 7x and the 1. Okay. And then if we look on the other side, we have the same situation. We can distribute the 3 to the 4x plus 3 because we have multiplication out here and addition on the inside. So we're going to distribute that as well. Okay. And this x minus 5 is put in parentheses. We're grouping the expression together, but because it's the first expression, it doesn't actually need the parentheses. So we can take it out. The parentheses don't make any difference. Remember, we're working left to right. So you'll see that as we work through this. So we have 4. And then when we distribute the 2, we wind up with 2 times 7x, which gives us 14x. And then plus 2 times 1. So we have a plus 2 here. And then on this side, we have x minus 5. I'm taking out the parentheses. And then 3 times 4 is 12x. And then 3 times 3 is just 9. Okay, and again, I say we could take out the parentheses around the x minus 5 because this is all addition and subtraction, so you just go left to right anyway. So x minus 5 comes first, left to right, so we don't really need to say it comes first. It's already coming first, okay? Okay, this is where a lot of people run into trouble, okay? The next thing that you want to do is you want to combine your like terms. Now, you don't have to do that, okay? There are other ways of doing it, but it's the safest thing to do so that you don't wind up subtracting 4 from here and subtracting 4 from here. Remember, you only subtract it once from each side, okay? So we're going to combine like terms. So let's just write this down, that there is an order to this, okay? Your first step was to distribute. And then once we distributed, our second step is to combine like terms on each side. So first work with the right, then work with the left, or vice versa. So on the left, 4 and 2 are like terms, so we wind up with 14x plus 6. And then if we look on the right, x and 12x are like terms. We're adding them together, so we get 13x. And then negative 5 plus 9 gives us a positive 4, so we get 13x plus 4, okay? So again, if you want to subtract 4 from both sides to get rid of it, that's fine. But make sure that you're actually subtracting 4 from each individual side one time and one time only. Don't do it twice, okay? Make sure that you're not subtracting it twice from the same side. So in other words, if you subtract 4 from this, don't subtract 4 from the 2. That's why I would suggest that you combine like terms on each side first, okay? And then our next step is just to solve the equation. So you want to get your x's on one side. And your numbers, or we call them constants, because they don't have anything that's changing. Okay, and I'll write this down now. Your last step would just be to solve for x. Okay, so now we're at the point where once we distributed and we combine like terms, we're right back to equations that look like this. So let's get the 13x over onto the left, okay? And that means that if we get the 13x to the left, we have to get the 6 over to the right. So we're going to subtract 13x from both sides. And then we're going to subtract 6 from both sides. And notice on the left, the 6 goes away, and on the right, the 13x goes away. And this is kind of nice because we don't have to do anything else, because what we get here is just x. So x is equal to 4 minus 6, or negative 2. And that's our final answer. Okay, and let's do one more of these. I'm only doing one more because you should be this is not a difficult problem. What I would recommend though is before you watch me go through it, I do recommend that you try it yourself. So we'll do one more like this. Let's do 7 times 3x minus 2 plus 5 is equal to 2 times 4x minus 1 plus 3x. Okay, let's solve this. So again, first thing, just distribute. Get rid of your parentheses first. And you're going to find that throughout this class, we do a lot of simplification. And the first thing that we always do in all of these simplifications is get rid of parentheses. Okay, so we get rid of parentheses by distributing. We can distribute in both of these cases because we have multiplication on the outside, and then over here, addition and subtraction on the inside. Okay, so when we distribute, 7 times 3x is 21x. And then negative 2 times 7 is negative 14. And then we still have the plus 5. And then on the other side, 2 times 4x is 8x. And then minus 2 plus 3x. So notice no more parentheses. And then we just combine like terms. So on the left, negative 14 and 5 are like terms. That gives us negative 9. And then on the right, 8x and 3x are like terms. So that gives us 11x. And now again, we're right back to where we were before with the other equations. So we're going to get our x's to one side and our constants or numbers to the other. So I'm going to subtract 11x from both sides. Again, that's because it's going to give me a positive x. You don't have to do it that way. I just prefer it that way. So we're going to subtract 11x from both sides. And if our 11x is going to go to the left, then our plus 9, our 9, has to go to the right. So that we should be crossing out one thing on each side. I'm sorry, I don't know why that did not come out well. Sometimes it doesn't work out the way that we want it to. Let me erase this and try and do it again. I apologize if you hear my frustration on these videos. It's the trouble with technology. I will try this one more time. Okay, that's the best I could do. I'm sorry. This is a plus, and then over here, this is also 9. Okay. Okay, so 21x minus 11x gives us 10x. And then on the other side, we have negative 2 plus 9, which gives us a positive 7. And we're solving for x, so we divide both sides by 10. And you would leave it as 7 over 10. Don't convert it into a decimal. Okay, and that would be your final answer there. Okay. Okay. Let's add a little piece to this. Okay. The little piece that we're going to add is fractions. We all hate fractions. So we're going to find a way to work with the fractions so that we don't have to worry about adding and subtracting fractions. Okay, so what do we mean? Let's say, for example, that we had 7/3 x minus 1 over 16. Not 1 over 16, 1 over 6, sorry. is equal to 4. Okay? Okay. This is messy, right? Because ideally what we would do first is we would add the 1 over 6, but we don't want to do 4 plus 1 over 6. So ideally what we want to do is get rid of the fractions first, okay? So let's write that down. And how do we do this? We find the lowest common multiple of all of the denominators, and we multiply. And it's not a difficult process, actually. You just have to be a little familiar with your factors. If you're not familiar, it just takes you a little bit longer because you have to use your calculator. So we're going to find the lowest common multiple of all the denominators. And multiply that by the whole equation. Okay, so what do we mean? What you're going to do is you're going to go to the denominators and you're going to look at the largest denominator. And you're going to say, is it a multiple of every other denominator? So I want you to keep in mind that this has a denominator of 1. And when we say, is 6 a multiple of all the other denominators, we're saying if we take 6 and we divide it by each of the other denominators, do we get a whole number? So 6 divided by 3 is 2. So yes, we get a whole number. 6 divided by 1 is 6. We get a whole number. We're good to go. Okay, so we're going to multiply the whole equation by 6. If this were not true, then we would have taken double 6. We would have done 6 times 2 and tried that. So we would have said, okay, 6 isn't good. Let's see if 12 works. If 12 didn't work, we would go up by 6 more and we would see if 18 works. So we'll do one where it doesn't just work right away. But here 6 works, so we don't have to do anything more. So we're going to multiply the whole equation by 6. So I'm going to put the whole thing in parentheses. I'm going to put a 6 in front of it. And we're distributing that 6. Okay, now there are 2 ways that you could go about this. So I'm going to do it in the slightly longer way for people who are not as comfortable with fractions, but you can do it in any way that you want, okay? So the slightly longer way is to actually multiply, and please keep in mind this is 6 over 1, not 6 over 6, okay? The longer way is actually to multiply the numerators together. So 6 times 7 is 42, so you get 42 over 3. Whoops, let me put that in a different color. Just that you know that it's not what we're working on. So 42 over 3x, and then we have minus 6 over 6 is equal to 24 over 1. Okay? Then you go through and you simplify. So 42 over 3 is 14. 6 over 6 is 1. And 24 over 1 is 24. Okay? Now, for those of you who are more comfortable with fractions, you might know that you could cancel. 3 goes into 6 twice, so you would do 2 times 7, which gives you 14. 6 goes into 6 once, so you would do 1 times 1, or 1. And here, it's just a 1 in the denominator. So you multiply the numerators and you get 24. So if you're comfortable with reducing from there, that's okay. If you're not, then just multiply the numerators and then simplify. Okay? And now we got rid of the fractions. We don't have to worry about the fractions anymore. So we just solve this the usual way. We don't have to do anything with the 14x because it's already our x's are on one side of the equation. So we're just going to move this 1 over and we get 14x is equal to 25. And we divide both sides by 14. This does not reduce, right? They don't have a common factor. So we just say that x is equal to 25 over 14. Okay, and that's our final answer. Let's do another one with fractions. Let's do 1/3 x plus 3 over 5 is equal to let's say 3. Okay. So this is an example where if we go to the highest denominator, so we're going to the greatest denominator, okay, and we're saying, is it a multiple of every other denominator? So keep in mind that this is a 3 over 1. So is the greatest denominator some of you may be able to do this much faster, but this is a method that you can use that will always work. So is the greatest denominator a multiple of all the other denominators? Okay, if it is, that's what you're multiplying by. That's your least common multiple. If it's not, keep multiplying, keep adding it to itself. Until it is. Okay, so 5 is not a multiple of 3. So that means that we have to keep going. So 5 is not the least common multiple. So we're going to take 5 and we're going to add it to itself, and we get 10. Now 10 is also not a multiple of 3. So we're going to add it to itself again. And we get 15. So 15 is a multiple of 3 and 1. Okay, so this is good. Okay, so keep in mind what we did. We added 5, and then we added 5 again. That's how we got the 15. Okay, so what does this mean? This means that we're going to multiply everything by 15. 15 is the lowest common multiple. Okay. And remember, you're multiplying it to everything. Don't forget to multiply it to the other side as well. Okay? If you have to show that you're multiplying on both sides, but you have to make sure that you multiply everything by the 15. So again, there are two ways that you could do this. You can start by just reducing the fractions right away. 3 goes into 15 5 times, so you get 5x. Or you just write it as 15 over 3x plus 15 times 3 is 45, so 45 over 5x is equal to 45 over 1. Okay, again, remember that that's a 15 over 1. So what do we get? 15 over 3 is 5. 45 over 5, sorry, there's no x here. 45 over 5 is 9. And we get 45. Okay, and now it's just a matter of getting rid of the 9. So we subtract 9 from both sides. We get 5x is equal to 36. And then divide both sides by 5. And there are no common multiples. So you can see that most of the time, there's no fraction to reduce. That happens most of the time. But you should always check for it. You should always check to see if the numerator and denominator have something in common that you can divide by. Okay. Now we're going to do one more. I want you to try this one on your own first and then restart the video to see if you did it correctly. Okay. So let's do 3 over 4x plus 2 over 3 is equal to 5 over 6. Okay. So again, we need to solve this. So we have a fraction on this side now, which doesn't change anything. We're going to go to the 6 and we're going to say, is this 6 a multiple of every other denominator? And it's not, right? 6 is a multiple of 3, but it is not a multiple of 4. So what we're going to do is we're going to add 6. And we're going to say 12. And is 12 a multiple of 3 and 4? And the answer is yes, it is. So this will be our lowest common multiple. So what we do is we multiply the whole thing by 12. Again, if you're good at your canceling, remember that this is like 12 over 1. If you're good at your canceling, you can skip the next step. Okay, and go directly to what would be the equivalent of this step here. Okay, so 12 times 3 is 36. So we have 36 over 4x. Then 12 times 2 is 24, so we have 24 over 3. And 12 times 5 is 60, so we have 60 over 6. Okay, and we're just reducing these fractions. And you should be getting a whole number. If you don't get a whole number, double check your multiplication, but then also double check that your least common multiple is correct. Okay, so 36 divided by 4 is 9. So we have 9x. 24 divided by 3 is 8. And 60 divided by 6 is 10. And then we just subtract 8 from both sides. That 8 goes away. And we wind up with 9x is equal to 2. And we just have to divide both sides by 9. And this is how we deal with linear equations that have fractions. So we are essentially doing one extra step where we get rid of the fractions, okay? And you would do this even if you had an example like this. If you had any fractions here, you would just multiply everything by that fraction, by the least common denominator, okay? Okay, so we're almost done with the equations. Our next step is a slightly different type of equation called absolute value, okay? So we're going to do an absolute value equation. But in order to do that, we're going to have to talk about what absolute value means. Okay, so, and we're only going to be looking at linear, okay? So in other words, what is inside the absolute value is going to be a linear equation. Now, what do we mean by absolute value so that that statement makes sense? Absolute value is a distance from 0. So I want you to think of a number line, okay? And on a number line, we have 0. And then let's say that we have 4. We also have -4. And both of these are exactly 4 units from 0, right? This is a distance of 4, and this is a distance of 4. The positive and the negative signs have to do with direction. The positive sign says we're to the right of 0. The negative sign says we're to the left of 0. But sometimes we don't care about direction, okay? If you think about adding and subtracting negative numbers, okay, the negative just means you're going to the left. Anytime that you see a negative sign, it means that you're going to the left, okay? And if you see 2 negative signs, it means switch direction. So that's why if you see, let's say 3 minus -4, the initial minus means go to the left, and the next one says, switch directions, actually go to the right by 4. That's adding and subtracting negative numbers, okay? A negative is just saying you're to the left. You're traveling to the left. A -4 says go 4 units from 0 to the left. Absolute value says we don't care which direction you're going in. We just want to know what's 4 units away, okay? We don't care if it's to the left or to the right. We want to know all of the numbers that are 4 units away from 0, and there are 2 of them. There's 4 and there's -4. We want to know all of the numbers that are 7 units from 0. There are 2 of those, 7 and -7. If we want to know all of the numbers that are 9 units from 0, there are 2, 9 and -9. We don't care what direction it is. We just care that there are 2 numbers that are 9 units from 0. So the way that we describe this is using absolute value, okay? And the way that we show this is with 2 bars. So we say the absolute value of 3, let's say, is 3. 3 is 3 units from 0. The absolute value of negative 3 is also 3. 3 is 3 units from 0. Negative 3 is 3 units. I don't know what I was thinking of writing. 3 units from 0. That's why they're both equal to 3. The absolute value of negative 11 is 11, because negative 11 is 11 units from 0. The absolute value of 1002 is 1002. 1002 is 1002 units from 0. And finally, the absolute value of negative 103 is positive 103. Because negative 103 is 103 units from 0. So I want you to know, absolute value is always positive. Okay, so what does this say about equations? Okay, let's say that we have the absolute value of x is equal to 8. Okay, well, what does this mean? X can be one of two things. Either x is 8 or x is negative 8. Okay, because the absolute value of 8 is 8 and the absolute value of negative 8 is 8. Right? This is because the absolute value of 8 is equal to 8, and the absolute value of negative 8 is equal to 8. So x could be one of two things. It could be 8 or it could be negative 8. It could be positive or negative. And in both of those cases, the absolute value will give you positive 8, right? Absolute value of 3 is 3. Absolute value of negative 3 is also 3. Absolute value of x is 8, so x could be positive 8 or negative 8. Absolute value of x is 4. If that were true, then x could either be 4, that's 4 units from 0, or it could be negative 4, because negative 4 is also 4 units from 0. So this is saying x is 8 units from 0. So x is either 8 or negative 8. If we say that the absolute value of x is 5, then x can be 5, or x can be negative 5. Okay, so again, what are we saying here? We're saying the absolute value of 5 is 5. We're saying the absolute value of negative 5 is 5. Said in another way, we're saying x is 5 units from 0. So x can be 5, or it can be negative 5. That's what we're saying here, okay? Now note, I want you to note this. What do you think would happen if we said that the absolute value of x is equal to negative 7? Wait to think about that for a second. We're saying the absolute value of x is equal to negative 7. That means that we're saying, let's go back here for a second, x is negative 7 units from 0. That's not possible. Absolute value isn't negative, okay? We can't say that x is negative 7 units from 0. Absolute value is not negative. So what does that mean? There is no solution to this equation. Absolute value must be positive. Okay, so that's our simplest equation. Let's add just a little bit to these, okay? First thing that we can add, let's start, I'm going to put a 1 here. First example, okay? Let's say that we put an expression in here instead of just a variable. Absolute value of 2x plus 1 is equal to 6. Let's think about what this is saying. This is saying x is 8 units from 0. So this is saying that what's inside the absolute value sign is this many units from 0. So what this is saying is that 2x plus 1 is 6 units from 0. So what does that mean? We actually have 2 possibilities for 2x plus 1 because there are 2 numbers that are 6 units from 0. Either 2x plus 1 equals 6 or 2x plus 1 is equal to negative 6. So we have 2 equations that we're solving. All absolute value gives you 2 equations unless there's no solution because it's negative, okay? So now we just have to solve these 2 equations. And we could actually do it simultaneously. We're subtracting 1 from both sides in this equation and from both sides in this equation. So we get on this one, 2x is equal to 5. And on this one, we get 2x equals negative 7. And then in both of each of those, we're dividing by 2 on both sides. So what happens here is we actually get 2 solutions. So the way that we write it when we have 2 solutions is we say x is equal to, and then we use a brace. So if you look on your computers, this is what's above the bracket. Okay, it's called a brace, and it tells us that we have a solution set. Now, you don't have to put this in any particular order. You may just want to get into the habit of putting it smallest one first, but you wouldn't be incorrect if you wrote the 5 halves first. Okay, so we call this a solution set. And it's a solution set because there's more than one solution. And we write it with these braces. Okay, we just have a couple more examples. We'll do a couple of more. Let's say that we have 3x minus 7 is equal to 4. Now, to save a little bit of time, because I know that this is already a long video, we're going to write out the equations that we get from the absolute value, but we're not going to come up with the solution sets for all of them, okay? I'll give you the final answer. I'll give you the final answers, but we won't come up with all of the solution sets, okay? Just to save a little bit of time, but it's great practice for you to actually solve the linear equations and make sure that you actually know how to do it, okay? So this one, again, this is saying that 3x minus 7 is 4 units from 0. So what we're saying is either 3x minus 7 is equal to 4, or 3x minus 7 is equal to negative 4, because there are two numbers that are 4 units from 0, 4 and negative 4. And here, from this one, we get 11 over 3. Okay, that comes from this equation. And then from this equation, we get 1. Okay, let's take another kind. Let's say that we have the absolute value of 2x plus 4 is equal to 4x minus 6. Okay, well this is saying 2x plus 4 is 4x minus 6 units from 0. Well, either 2x plus 4 is equal to positive 4x minus 6, or it's the same thing. It's equal to the negative, okay? So it's either equal to the positive of the right side, or it's equal to the negative of the right side. So our second equation is 2x plus 4 is equal to negative 4x minus 6. Okay, so the left side equals the positive of the right side and the negative of the right side. These are your two equations. That's always the case. So here let's go through this solution. We can distribute the negative sign. Okay. And we get 2x plus 4 is equal to negative 4x plus 6. And then if we solve this equation, we can subtract 2x from both sides and add 6 to both sides. 2x's cancel. 6's cancel. And you get that 10 is equal to 2x. And then divide both sides by 2, and you get that x is equal to 5 there. And just over here, while I'm in the same color, we can add 4x to both sides. And that means we would subtract 4 from both sides. So the 4x goes away, the 4 goes away, and we wind up with 6x is equal to 2. Here we got x equals 5. Here we get x equals 2 over 6, or 1/3. Okay, so you're dividing both sides by 6 here. And this is an example where you would not leave it as 2 over 6. You would reduce that fraction. And then you should write it using the braces. The reason for writing it as a solution set is it's a signal to everybody that these are all of your solutions. You didn't leave anything out. You're done with the problem, okay? This says, I'm done. These are all of the solutions that exist. Now, there's another case with absolute value. The other case is if you have absolute value on both sides. So let's just say that we have absolute value of x plus 1 is equal to the absolute value of 2x minus 3. And actually, this doesn't change anything, okay? It doesn't change anything. It's the same thing. The left side is equal to the right side, and the left is equal to the negative of the right. Nothing changes here, and we'll show why in a second. So we have two equations still. It's x plus 1 is equal to 2x minus 3. Left is equal to the right, so you just drop the absolute value signs. Or x plus 1 is equal to negative 2x minus 3. Okay. And if we solve these equations through, here you get x equals 4. So you should try and solve these yourselves. Actually, let me put that in black. I'm not going to go through the solution for you. I'm just going to give you the answer, so you should go through and do the solutions yourself. Okay, we subtract x from both sides, add 3 to both sides, we get x equals 4. Here we distribute the negative, so I'll write that. We get x plus 1 is equal to negative 2x plus 3. Okay, so that gives us x is equal to 2/3. And we would write our final answer as 2/3 comma 4. Remember, there's no specific order here. Okay, and your braces don't have to be perfect. Okay, there's one last. This is truly our last example. The last example would be something like absolute value of 2x minus 7 plus 4 is equal to 2. Okay, and this is special because we have an absolute value, but we also have something outside the absolute value. This is really key, and it becomes very, very important. You must isolate your absolute value first, okay? And I realize I didn't explain this. I'll go back to this in a second. But here, you must isolate your absolute value first, which means get rid of the 4, okay? And this, it becomes true in so many different problems that we do. This is going to be a theme throughout the semester, where you see it with logarithms, you see it with radicals, you see it with trigonometry. We isolate the absolute value first. Okay, and the reason for that is that we don't know how many units 2x minus 7 is from 0, right? This doesn't tell us, because we have this extra plus 4 here, which gets confusing. How many units from 0 is it? I'm going to change this to a minus 4, because otherwise it makes this a problem. Okay. So in order to take care of this, we add 4 to both sides. Right? If I had left it as a minus 4, then we would have wound up with a negative value on the right, and we wouldn't have had a solution to the equation. So that's why I switched it to a -4. So this says that we have the absolute value of 2x minus 7 is equal to 6. So 2x minus 7 is equal to positive 6, or 2x minus 7 is equal to negative 6. Okay, and this one gives us x is equal to 13 over 2. This one gives us that x is equal to 1/2. And the last thing here is, why does this work this way? I want you to consider, I'll put this in purple because it's a slightly different explanation. I want you to consider absolute value of x is equal to absolute value of 4. Then it's also true that the absolute value of x is equal to the absolute value of -4, right? That's true as well. So what we're saying here is x could be 4, because the absolute value of 4 is 4. And x could be -4, because the absolute value of -4 is also equal to the absolute value of 4, right? Think about it this way. Absolute value of 4 is equal to 4. Absolute value of -4 is equal to 4. So if we say absolute value of x is equal to absolute value of 4, then this is what we're saying. X could be positive 4 and x could be -4, because in both cases, okay, you're going to wind up with the same answers. I hope that was clear. In other words, if we put the absolute value on this side, it doesn't change the fact that this could be positive or negative, because we're making it positive. So if this were a positive number, it doesn't change the fact that this is positive, right? Then both sides are positive. And if this were a negative number, it still doesn't change the fact that we have the absolute value, okay? So if we have absolute value of x equals 4, equals the absolute value of 4, x could still be 4. That's still true. And x could still be -4, because the absolute value of -4 is also 4. So it doesn't matter. The absolute value on the left doesn't change any, on the right doesn't change anything, because this, no matter what it is going to give us something positive, and or we could have something negative in there. It doesn't change the fact that we have a positive. Okay, this is kind of just saying you have a positive. And the only other thing is, any absolute value equation gives you 2 equations to solve. Notice in every one of these 5 examples, there were 2 equations that we solved in the end, okay, right? One where it's equal to the positive and one where it's equal to the negative. And that's it for equations, okay? In our next video, we'll start talking about inequalities, okay? Okay, I'll stop there. This is definitely long enough.